This is the Nephew SDK meeting for February 27th, 2024. Anyone has anything to talk about? I mean, I've been like really lacking on the agenda stuff. But then again, experience with the agenda docs is people also don't really feel it out. So it's kind of hard to know.
Yeah, I'm working on Keyform to get something to you guys.
Okay.
But it's probably going to be, I guess, next week. Yeah, I'll see how far I get because I'm pretty busy with stuff. So I try to get something out of the door.
Okay.
ASAP. But it's probably expected next week or something.
Okay. Nice.
I don't know whether there are people who had questions or I can answer some questions.
So last week, from what you've shown us, there are things that you plan to do but haven't done yet, which is the control runtime hooks that doesn't seem like it's there yet. So right now,
yeah, I didn't do because you can do that independently, by the way, in my view, right? So that's someone who can basically look at that. I mean, I've done it in the past, so I know how to do it, but I was not planning to focus on that. So I was more planning to focus on the core.
So if
someone
that's
could,
the case, yeah. So if that's the case, what is the output form? So what is the thing that's generated? So your translation logic by itself would be a binary, or do you want
no.
The idea would be the tools itself would have a control runtime hook, so that if you when you're creating that piece of logic which maps resource fields to resource fields, resource A and B fields to resource C fields, that is an executable binary somewhere that you'll be able to combine.
Here is how I think it'll work, right? So one is we have a binary, right? That Nephew owns, which is based on the controller runtime with some hooks, right? So when you deploy this binary, you will and that's a discussion, right? That we have to have is you basically say this controller uses this config map, for example. So you insert your deployment, right? So you can mount and the format I don't mind, right? Either way. But that config map basically contains the resource, your business logic, if you will, right? Is the resources that and your business logic to render. So I think of it as a config map, can be any other resource that we can think of, but that's the thing that you hook into. So when the binary starts up, what happens is you read the config map and you basically, if you will, it's not really compile, it's interpret the configuration, right? And out of that, what comes out of it is you create a DAG, basically. So it's an execution context that I call, right? And so that you have to map to as part of the config, you can have multiple execution contexts, by the way. So you can have, what I did in the past, I had a separate one for delete and another one for update and create, for example. Okay, because you typically have a different behavior that you do, right? So what I was doing is that in your config map, you also define the hooks, right? So for example, you can say, so what I did is I had a GVK, right? So I said, and in our case, this is NF deployment. You probably have to say this is the provider, right? So you say NF deployment is the resource, the provider, and then I created a hook for a delete and a create and update, right? And then you could also have watch hooks, right? So you could say, I want to watch this resource or something like that. So that's what you specify in the config map. So when the binary starts up, it reads the config map. It basically creates your execution context and assigns it to the watches that control runtime has. That's kind of what happens. Now, then when you get a CR, it basically runs the business logic, right? Depending on whether you get a delete or a create update. So it actually runs the execution context and it will do the stuff that you have configured it to do. That's how it works.
Okay. So the tools the tools at compile time generates a config map, and it will include that config maps on the package,
Yeah.
on the operator package in this case, the operator package, and we have to write a operator dummy operator, well, a control runtime operator that hooks up with that config map. Different logic. How is that represented on the config map? So if it's delete, you do something different. Is that code, or is it more like?
No, it's another pipeline. It's another execution context. So you can assign an execution context based on those watches, or both based on those hooks, I call them.
Okay.
That do this. So what I ended up doing when I built this, right? So in controller runtime, there is a builder, right? When you so you're set up with manager, right? Then you say build this and that, right? So that's what happens. So I create my own builder, which is more or less the same as what is there, but it's a way to execute to assign these hooks into that workflow. That's what I ended up doing.
Okay. Okay.
So which is the amount of code was 100 lines or something.
Okay. No, okay, that makes sense. I mean, I don't know, because at this point I didn't know where you were, so I haven't done it yet, but I was thinking of, because I mean, we talk about that later, because Fiacra and La Penta has done the POC part. So the next thing would be hooking it up with some operator, to ensure that we would be able to realize what are the pieces now outside of the business logic, which is important. What are the additional things that are needed? Then we can talk about that later. So cool.
Yeah, so what you can do right now, independent of what I'm doing, is you can basically look at the controller runtime and create that logic, right, that I was just describing. You can do that and basically say just print hello world out of the hook, right? And that's so you can do that completely independent of what I'm doing at the moment.
Yeah. So yeah, let me take a look at that. Yeah, because this is already brought up. I mean, and then so it'll be nice to start making progress off of hooking up with something.
Yeah.
So
I can help later, but at the moment I'm too busy.
Yeah,
with
that's fine.
Too many things. So I want.
It's unreasonable to say you do all those stuff. So this is
correct.
It's
so
already
I would
a lot
like
of
someone to.
Yeah,
to
I'll take a look at that. It's like,
I can give you some pointers if you want.
Yeah, this is basically the base operators, where all the hooks are created, so that you can hook up with business logics, including the fact
look
that
at the builder. So the code where you have to hook, right? So I can show you quickly, maybe.
Yeah, I mean, it's the operator, the builder, and set managers and operator of the thing that you generate from QBuilder, basically. This is
so when you wait, so where, if you take our nephew code, right?
Yeah.
I was just looking at the nephew code here. So if you let me share my screen quickly.
Yeah.
Let's share screen here. Okay. Now the question is which screen? Because you see my screen?
Yep.
Okay, so where you have to hook, I just take the specializer here, one of the others, right? So where you have to do the hook is here. This is where you execute, where you hook it up.
Yeah.
If you look at this, so this is kind of builder code of controller runtime. If you go here, right, this executes a builder. So this is alias, right? So there is, so there is a builder behind this code that sets up the controller. And if you look at the builder, it's a set of, for every 4, you have a watch. And for every, so if you go and create so if you go and GitHub controller runtime, I don't know whether I will get there, but let's see. No. Controller runtime. Yeah. So if you go here, package, here, builder. This is the code where you have to look at. This is where you hook the thing up. You see, so for input, right? So here the for. So if you write a for, that's where you get a for, right?
Right.
If you do the own, that's the owns, right? So here is where you have to hook it up. Watches. So this is basically what I ended up doing when I did it 2 years ago. I created my own builder, basically. So I mean, you create your reconciler, you attach your builder, but it's a rewrite. It's a bit of a refactoring of this code, but all the rest stays the same. So you don't touch anything else. And then you get all the features of controller runtime.
Okay.
Right.
Okay.
Yeah. Because then when they do evolutions, right, you don't basically change much. Actually,
well, we hope we can run around. We can run with the controller runtime library.
Yes, you get all the caching and all the indexing and all that stuff out of the box.
Okay.
Yeah. Yeah. So this is where you have to hook it up, I think, or at least that's my view.
Okay.
All right.
Okay. Yeah. Yeah, because now it's just for ohms and watches.
Yeah, but a for is a watch basically, right? So if you look to the implementation, if you go to this code, right? So if you look to the for, it creates a for object, which is input, right? And then yeah, for input somewhere. Build, right? And then it do controller, right? And then this is R, so this is the reconciler basically. And then here, see, it's do watch, right? So the input is a watch. You see? So they're all watches basically.
Yeah.
But the for is kind of a special one because that's where you hook up the reconciler to. But
yeah, because that's where
all the others are also watches.
Yeah, because I did watch too, but then watch only gives you a callback, and then it asks you to reinvoke the reconciler.
Yeah. But here, this is kind of your codes in the reconciler, right? Is kind of the same as what you have, right? Wait, so the way it's not 100% correct what I'm saying. So the code that I used to do was the following. So basically, I had this builder, right? And I put my execution context, which I built from the config map. I gave it here, right? So you basically, because when you set this up, so the flow is the following. When you set up the controller with the config map, you kind of compile your execution context, if you will. It's not really true compilation, right? Because it's interpretation, but you basically compile your business logic, if you will, what Kform does, right? So it basically generates a DAG at the end of the day. And the hook of the DAG is your watch. So basically, when you get a for resource, you basically start triggering execute the DAG, right? And then it will do if this, then that, depending on how you configure it, right? So when your controller starts up, you give it a config map. I mean, we could even do more advanced stuff. You could basically give it, I think we should start basic, right? But you could even point the logic to be a Git reference, right? So you could even get it from Git if you want, and then the controller will have to upgrade when there is a new revision, right? When you change the config map. So you have to build some logic in there. But okay, let's leave that aside for now, right? So you build so when the binary starts up, if you will, it looks at the config map. If it's not there, it probably reboots, right? So it will say not found. If it's there, it compiles it. If there is an error, it will return. It will say, okay, what you give me, I cannot do anything with. It doesn't work. Here are the issues. If it's compiled, right? So then you get your execution context, which your builder will attach to this piece of code, right? And then it will execute. That's what you have to do, I think. Right.
Okay. But then your input, your config map inputs, do you come in with a piece of code on delete logics? Is that what you're thinking of doing?
No. So for each of the for each of the watch. So in other words, you create an execution context for every watch you want to attach yourself to, right? So now when you want to split delete from create and update, and what you have to, so you basically build a reconciler, right? So you attach your execution context to the reconciler.
Yeah.
And the first thing you do is, so this code you can keep, right? Because I remove this and make it unstructured, right? Right. And then the first thing you do is so this code would be different. So if deletion timestamp is X, go to execution context delete. If not, go to execution context update and delete. So that's what you would do. And then for the other watches, so the non-4, if you have also owns and other watches that you want, you also have an execution context for each of them. And you could, so there's multiple ways to implement it. You either do it with multiple config maps that each identify these execution contexts. But initially, we should start simple, I think, right? So just do a single resource, right? And then attach it to it. And then we can, once you experiment and get more familiar with it, you'll see how to do it. It's rather straightforward. Right?
Okay.
So with the simple sys, okay, you could start with a single thing and not do anything with delete and create an update, right? In which case you have a single execution context, and you could either attach it straight after this thing here, right? Right. Because this is basically giving you NF deployment, right?
Yeah, the reconcile is on NF deploy for sure. NF deployment is the thing you reconcile.
So what I did in the past is what I did in my code at the time was this would be NF deployment, right? And then what happened is if delete timestamp was X, I would execute my delete DAG, and if not, then I execute my update and create DAG.
Okay.
And that would be the simplest way to start.
Yeah. No, that was my plan of doing a dummy operators that watches on NF deployments, and that will be hooking up with logics that is pluggable, I guess, in this case, that will be able to create what is needed for the Flux to work. I mean, that piece of logic is also, even Flux or not Flux, but Flux is creating config maps off of the translations. But then the big point is the translation logic is to be detached from the operators. It's not implemented as this. Okay. Yeah. Let me take a look at that. Cool.
All right.
Okay. So and so one thing, I have a repo created for our POCs, if you will, on doing this. So it's here on Nephew Experimental, Nephew SDK POC. So we'll do our first cut integrations on over there, and as they become more mature, I guess, or as we get closer and closer to R3, we start moving things into the SDK repo. This is where we can experiment on things. We can throw away stuff and things to get at least the integrations for multiple people, hopefully multiple people that are working on the projects. So this is the integration branch that we can repo that we can play with first, and then as we get closer and closer, we'll start moving things into the official SDK repo. Neither repo has an owner's files or the proud.yaml that is enabled. So it's not like they're like ready for contributions yet. So let me add the owner's files. I can make everyone an owner. Well, everyone. It's not everyone yet, but everyone in the team an owner, so that we can kind of merge each other's code. into a PLC repo. And
I'm sorry, I made a miss last meeting, but from the base tooling perspective, where does operator SDK stand in terms of being a candidate for a base tooling for this?
I think that piece, Dijon volunteered, and he's not here today. So I can ping him to see where we go.
Okay.
Yeah, that's the piece.
Like I said, any I can also talk to internally from the Red Hat folks. I personally believe that may be a good choice because of the other options that you mentioned, like Ansible and Helm and other options. Maybe so. I think.
Yeah. No, agree. So the whole point would be, if we are going with that, then the responsible contributor is going to look into how to create a CLI wrapper around this, and how do we leverage, and how do we go from wrapping this and, let's say, creating my own extension CLD, and then also eventually hook up with Vim's tools if that's the direction we go, and so on. So unfortunately he's not here, but that's definitely a really big piece that I would like to see, and we make a decision soon, and at least POC prototype it so that we can see it works.
Yeah.
On the use cases that we're looking at.
Yeah.
And so cool. Outside of that, so for last week, Lepenta and Fiacra make some progress on our first POC, if you will, which is bring up the entire FreeFiGC network functions using Helm with Flux. And if you take a look at that, so some of these are, so these are creating management clusters and things, which is fine. So we have our way of doing it. And then we have to install Mongo. And so now one of these is to put Flux onto management cluster. Okay. And then there's something here to actually show you how to do it. So this is, I guess, Fiacra is still not back yet, I guess. And Lepenta is not here. I was just wondering, this install Flux onto the management cluster, but then the idea actually we had is to use the Helm controllers from Flux, and then run it locally in the workload clusters, and then try to pull a Helm charts directly from some repos that are accessible by workload clusters and bring it up. I think we can. I'm sure this actually installed the Flux Helm controller. So this is actually on management cluster in this case. So that pulls from the repo Helm charts, and so there are a couple of questions I have. If we want to run this on workload clusters with our default operators, if you will. One of these is where's the repo information for where your Helm chart sits. So this is one question that I have. So we have to input that onto for the SDK perspective during runtime now, and at that point that information needs to be in the NF package when you deploy it. So we have to know which Helm charts it's actually pointing to. So in this case, I'm sure that's also specified somewhere.
That should come with the NF deployment, not as a config rep.
We could make it into a vendor extension, if you will.
Yeah.
In that case, they push it inside the config raft, and then NF deployment will parse it and understand.
Or update NF deployment if it's a key requirement. If it's there, you use it. So we can either. Right.
Well, this is how bring up use case. So if it's not, if it's probably
no, but you could also add it to the base NF deployment to say there is a Helm reference here or something. Either way, right? So because I think Helm reference is across vendors the same. I think. Of course, the destination is different, but the charts there is a single format. Sorry, Killian.
No, it's okay. I thought you'd finished. I think if you had a question for Faker, he's just arrived back now. So
sorry, it's popped away. Yeah, but I guess Davide isn't on the call here at the moment. But yeah, so we had a look at this, and it seems to obviously there were a few tweaks required to get it to deploy, but yeah, it looks as if it's functional. There was no attempt to test the end-to-end call, or we weren't really testing the FreeFive.gc charts themselves, but because I don't think they had been updated in quite a while. But yeah, everything was up and running, as you can see. That's as far as we went, I think.
Okay. So you have you directly using the Helm charts from towards 5GS.
Yeah, I'm pretty sure.
Where do you store it when you're doing this test? You store in Git repo, right?
I need Davide's input on this, but I'm pretty sure if we scroll down through, so I'm pretty sure he just pulled directly from the. If you go to, there's a link to the cat package. If you go down,
I think the last time you did this, you basically pulled it directly from the upstream Git repo, didn't you?
Yeah. So if we go up, if you go up to Internet Nordics package there for a second, so if you go to that one there for a second, Stephen. So and go up, we have the package. So that's the config map. But if you go up, Git repo, yes, I think so.
Okay.
Yeah, so it's pulling directly from Orange, yeah. And then your Helm release is your. That's the chart that you're looking to pull.
I see.
Yeah.
Okay. So that's pointing to the entire chart, basically.
It's pulling the parent chart. Yeah, it's pulling the parent. Yeah, with the nested siblings. Yeah.
Yeah. For us, that would be for each network functions. I think for the operator, but that's fine. I mean, it's obviously if it works there, then we work on the individual ones, assuming there's no interdependencies between them.
Yeah, I think there was obviously the different N interfaces. I think there was some slight tweaking there required. N6, I think. But yeah, as you said, I think if it works for the parent chart, then it should work theoretically for the children individually.
Okay.
Yeah.
And that's all that's needed for parent charts. Well, that's not a lot of that doesn't seem like a lot of parameters. That's kind of nice. Okay. So this so in terms of working, so this needs to be input it. That you need to load that into the gig repo, right? Also, once you have all the your config, this config map is the parameters config map, right? These are basically your values.
That's referenced in your Helm release, your Helm release YAML.
Oh, I see.
I'm pretty sure if you go back to the so at the config map here at the end, you're referencing
I see.
Yeah.
So you directly get it from a from mount point. So you have a config map in the pod. Oh, actually, this config map is
this that's just stored as a standard KRM, and then I think the Helm release passes that, or when the Flux Helm controller comes up, it passes
this is
config map value.
This is basically on this is on FCD. Yeah, this is basically on FCD, and then you save the config map on your demo repo or demo namespace, I guess, and then you created that config maps from. So this is done obviously done manually at this point. Oops.
Manual in what sense? But I think as I said, like as Tal pointed out, this is just a raw string. Like this is just this config map is just a raw string, really. The values YAML passed. But it's just stored as a config map within Kubernetes.
In fact, all of these are stored in Kubernetes. You actually apply all of this in Kubernetes.
Yeah.
Because I think your Flux controller is watching those resources, or at least understanding those resources.
Yeah, and obviously I'm pretty sure he ran it on the workload cluster, as before. So the Flux components would run on the workload cluster, I feel like.
And then the trigger would be you tell them exactly what the release is, and then this would actually deploy it.
Yeah, so as I said, there are the reconcile strategy there on 16. There's a couple of different, we played a little bit with that before, but that will trigger, either I think there's version or revision, and depending on your chart, minor, major version, it will trigger a reconcile.
So this workflow would be generating this, and then we already know we have to generate this, and then this is the one that you're gonna have to apply for the deployment, basically. Okay.
Yeah. Obviously, there's a hard-coded namespace there as well. I don't know whether that's a big deal or not, but
I mean,
the Helm release is the CR, I guess, for the Flux operator.
Yeah. So they're watching their own thing. Okay. So that's good. That's interesting. So that would be our trigger when, in terms of hooking up to business logic, the business logic would be applying this once this is generated. Okay.
Yeah, and I guess we'd have some way then of creating that config map for the particular function in the SGC, or sorry, in the SGK.
Yeah, I mean generating a namespace for these elements for these resources, and then stage them and then apply it would be part of the business logic for Flux from our operator side. Okay. Cool. Yeah, so we'll play around with that too. The goal is the controller runtime things that we talked about we like what I would like to see is what the gaps are in terms of how do we get to deploy it, and because this is all Flux specific logics, it's all business logics that would come in to go from reading a config map input to be able to and B, generating a config map that represents values.yaml, and also creating all the Flux resources, Flux Helm related resources, so that we can trigger the deployment. So yeah, so those are the things that.
Actually, I'm mistaken there. I think he runs on the management cluster, on a single cluster. If you did that,
yeah, I saw that. Yeah, I saw that.
Yeah,
I saw that earlier before you came back. I said, oh, this is our management cluster, but it's okay.
Yeah,
it's pretty. Yeah, it's pretty much the same logic, because for now, for the way this is done, it really doesn't matter. Yeah, this is more like this is making sure that we have the workload. So we have to code the workload basically in this case. This is not part of the Helm charts, so we have to do that outside to PV.
Yeah, there was some issue with the persistent volume. Yeah, I don't know whether that was domain specific, but yeah, there was an issue around MongoDB. I think Davide could speak more to that. Yeah, but again, that was kind of or kind of
okay. That's another. No, it's good to know. There's some. The operator would have to do some sort of prep work. That may have to be grouping some of the logics into prep work.
Possibly, possibly.
Yeah, I mean, loading CN9 and stuff like that. Those are already solved, I guess, by Nephew. But then Mongo installations and creating volume before Mongo, that's different. That's something we'll have to do. Go ahead, Akash.
Yeah.
No audio. No audio.
I can't hear anything at all. Sorry. Yeah, your audio seems to be pretty choppy, Akash. At least for me, I guess. Hopefully, if anyone can hear.
No, same.
Yeah. Can you hear me now?
Yeah, much better.
But is it better?
Yes.
Sorry, but my question was, is having the operator on the workload cluster, is it a sort of a standard which we are going to follow? Like, because this Flux operator is not going to do anything apart from deploying it, and it is going to is it something we are looking at it like, because it is not helping the workload run, it is just deploying the workload and it is going to stay on forever, right? So is it sort of a standard which you're going to follow? Because the workload cluster is essentially to run the workload alone, right? And it could be a noisy neighbor around the workload. And is it a sort of an accepted standard, or the same with config sync as well? But yeah.
In this case, we look at that as more like a dependencies for deployments. The reason we do run it on workload clusters, because obviously the operator runs on workload clusters. The network function operators that runs on workload clusters is for probably more future reasons. We would like to be as close to the workload as possible. So we'll be running the same clusters as the workload. And because that's the NF operator is the one that interprets our NFU CLs, the NF deployment at this point. So the NF deployment translation interpretations is essential to do deployments. As the name indicates, is for deployment of the network functions. So it's important as an input to our Helms. So in this case, yeah, we'll have Flux running. We have, as far as I know, I don't think we have any plan of saying that, oh, deployment done and then just turn it off. So that could be something we can do moving forward. But yeah, at this point, this is the Flux controller itself. Actually, that's a good question. The Flux does the Flux controller needs to run on the same cluster where the deployment happens? Fiacre?
I don't think we didn't look into that in detail, but there is I think there is capability there to run us in a centralized. I know Argo supports that, but I'm not sure about Flux. I think you can run it in a centralized deployment, if you like, of the Helm
We can probably
Helm
see
controller.
we can probably see by look at the Helm release resource. If the Helm release resources allows you to say this is cluster, identifying this cluster or something like that.
I think if it's just targeting the namespace, but I'm not sure.
Yeah, because it's actually a lot more stuff. It's like, oh, do you have the right to kube control the
but
kube config?
there would be there would be a whole lot of additional security and RBAC and all that kind of stuff to add if that was the scenario. But yeah.
Assuming it doesn't, that's another reason why I should run on the on the workload clusters. Anyway, I mean, for Akash's questions, it's a good question. It's the thing is, the fact that we're using this is because we want to leverage the Helm charts, but then deploying network functions, the control aspects, the network function specific control aspects, it's always been running locally on the workload clusters. The current version of the FreeFiGC operator invokes the API directly with the privilege that was given when it's launched as the operator. So we're not crossing clusters anyway. In that case.
Yeah, I think Akash brings a good point. I think having the network function operators is okay. I think probably they can do some lifecycle management or probably even do some closed loop automation locally. But in general, some of these clusters, especially the RAN workloads I'm talking about, they need to be extremely nimble, and in some cases they may not be hardware resources available. A lot of resources available for the CU type of workload or for some of the 5G core. I'm not too worried, but I'm mostly worried about the far edge where DU and other things are deployed, where the hardware resources could be constrained. That's where our deployment also needs to be a little bit more nimble and constrained as well. I think in those situations, if we deploy all this additional stuff, like Akash mentioned, we may have some resource issues. For example, let's say we're installing Flux, we want to install config sync, or let's say in case somebody else wants to do Argo CD, multiple GitOps solutions that needs to be there in order for this to work, and it's a for HDU cluster, extremely single node cluster, and then it has not many resources. We may get into that operational aspect. That is something I'm not suggesting we need to consider now, but I just want to keep that in mind in terms of some of our workloads that we're targeting, especially on the far edge side. They may have a very constant resource.
Yeah, if you look there, just I posted in the chat, it does have, so you can manage Helm releases on remote clusters.
I see.
With Flux. Haven't done it, haven't looked at it, but yeah.
Okay, go ahead, man.
Yeah, so I just wanted to comment about, I do agree with you, by the way, but on the other hand, I think the reason we have Flux at the moment, but I think all the GitOps tools support Helm, but not Helm with the hooks, right? So that's where Flux is the only one that really properly does that. So as long as we have regular Helm without hooks, we can use any GitOps tool, in my view, Argo, config sync, or Flux. But from the moment you get Flux into the hooks into the mix, then you are hooked to Helm to Flux. Sorry.
Yeah, that was
yeah. Sorry, too many.
That was a good rhyme, Wim.
Confused.
Yeah, no. That's actually that was perfect actually in my view. Thank you. So, in general, I do not have too much experience with the real world Helm scenario. So, how in terms of real world scenarios, do most of them have?
No. So obviously Helm is the command line tools. So you run it on something that has a kill config. So you can remotely execute your Helm charts deployments. In our case at this point, we want the execution engine runs on the workload clusters for now in terms of the workload. I mean, if it does become any issues, we'll probably start, try to see whether we can do something different. But let's take it, I guess, one step at a time as we go.
Yeah, but I was trying to understand Wim's comment. Do the real world Helm charts, do they come with a lot of hooks in general?
Oh, depends on
Kieran will chime in. Kieran has something.
Kieran can go ahead. Go ahead. Yeah.
Yeah, I mean, I guess the comment, Wim, on regular Helm versus Helm with hooks, I think I would have considered the Helm hooks as being a part of the regular Helm, as part of the sort of the full scope of what Helm does. And we certainly have seen quite a few Helm charts myself from within Ericsson and also from other third parties that use hooks quite liberally. Notwithstanding that, and I guess, Stephen, maybe I missed part of the conversation. I dropped briefly for a minute, but it's not just a CLI. There's also a library. So I guess it's the library that they embed into the Helm release operator from Flux, which does the heavy lifting. And I think we've discussed in the past that you could, in principle, take the Helm release operator from Flux and make it generic, so it's not actually specific to Flux. It's just an operator that works on a custom resource type, and then a Helm release custom resource type that is not specific to Flux, and then can leverage the Helm client API under the hood, as opposed to going and doing, I think, what the other reconciliation agents do typically is they take the Helm charts and they render them into using the templating mechanism before using the Kubernetes direct interactions, which is where the hooks get lost. So I guess if we wanted to break free of the constraint on Flux as a way forward, then having a standalone operator that just uses the Helm client under the hood and has a sort of a generic custom resource type like Helm release would be the way to go.
So this installs the Flux Helm controller. Does it actually install? I mean, question to Fiacra. Does it actually install?
Yeah, so you use source controller and Helm controller. Yeah. So your source controller is what controls your Git interaction, or your Git repo, your
one would imagine that, because otherwise they wouldn't be able to pull all the
and then your Helm controller is what obviously wraps the Helm library to deploy the chart, I guess.
Yeah, we'll have to see. I mean, the thing is, we can bring it up and then bring it down too. Only during the time of deployment, get some feedback, and then we bring it down. It's just that any updates moving forward would probably have to also work with them. We don't really have a system where we bring down and up things that easily. Okay. Cool. That looks good. So the idea for the next step of the POC would be to hook up our SDK control runtime, if you will, to implement to see what kind of things we have to implement in terms of making this successfully launched, all of those. At this point, this deployment eventually will be taken care of by the dependencies controller, or whatever Wim is going to call NFT infra thing. For the POC, I'll probably just bundle that into the operator package, so that it will just be brought up when we load the package. It's just a little easier. Without such a strong dependencies on the dependencies controller for now. And then the rest of them are basically what Wim and I talked about, writing controller runtime to right now maybe launch those logic and then eventually launch the execution context, the deck that would come from the tools. So I think that would be a good next step for us to do one simple integrations to ensure that we can do it using a operators that watches NF deployment. Particularly for UPF, my understanding almost is we probably don't even need much vendor extension outside of maybe the chart locations. And then when Dijon is here, that would be the further integration. So he and whoever else is interested will be working on CLI hooks integrations, and then generating package, and then once we have those, then that will be the final integrations. So hopefully we can do all that before the ONE Summit, so we have a very good understanding if the workflow makes sense or all the pieces are in place. So if there's something major that we missed in terms of the SDK. So that's the plan. Cool. Okay, so that's my part. Are we trying to run the controller runtime or our controller, our core default controller, default operator, and then write enough of the outside code so that this would be executing this flux pieces in place, and then we'll go from there to see what other missing pieces are. Okay. Cool. So we looking forward for Vim's code being available sometimes, hopefully next week. But in the meantime, I can write the base stuff, and even hook it up with this for now. That's a hardcode execution context pieces that will generate enough of information to see whether or not we have anything missing. Cool. Anything else from anyone? Any other questions? Cool. Well, yeah, we'll get 4 minutes back. Thank you for attending.
Thanks, Stephen.
Thanks, Stephen.
Thanks. Bye.
Cheers. Bye-bye.
Bye.
Bye.